we're working with a rational equation here. We're asked to find what k is equal to. Now, we've got a lot of k's all over the place. This is a really complex one, which is the reason why I wanted to make a video about it, just to kind of show you how to do it. Anytime you're dealing with any of these rational equations, the very first thing that we want to try to do is try to determine what the lowest common denominator is, the LCD. Now, in order to do that, I know that this one is k minus 3, this one denominator is k plus 1, this one is just k squared minus 2k minus 3. So I need to factor this one, and if we remember our rules of factoring, two numbers have to multiply together to give us this negative 3, but add together to give us this negative 2. So those two numbers would be negative 3 and positive 1. So I'm going to go ahead and factor this one on bottom now. Okay, now I didn't change any other values other than factoring that one right there. Okay, everything else remains the same. You could try to factor this one if you wanted to. I would recommend that you don't do that until the very end, because we'll be combining like terms down the road. Just the denominator is all we're really worried about in the beginning. Okay, now we have to look at this and determine what the lowest common denominator is. This one over here on the left has a k minus 3 and it times a k plus 1. This one's got our k minus 3 and this one's got our k plus 1. So the lowest common denominator here is k minus 3 times k plus 1. Okay, well that becomes vital information, because the next step, and this is one way to solve it, I believe this to be the easiest way, if we take and we multiply this lowest common denominator, this k minus 3 times k plus 1, times each one of these components here. Right here, this one right here we're going to multiply times this lowest common denominator. This middle one we're going to times this lowest common denominator, and this last one as well. Okay, so I'm going to bring that in, and I'm going to color them in blue. I colored them in blue just so that you can see where those came from. Okay, that is my lowest common denominator up here. You notice how I'm not going to go ahead and multiply these two in, FOIL them, or if you want to use the box method, you could, but it's going to make our life a lot easier to go ahead and start crossing off stuff top and bottom. So you notice this is k minus 3, and you notice that all of these went on the top. These are all on the numerator. The reason that is, if we're going to multiply each one of these 3 by it, this is the same thing as k minus 3 times k plus 1, all divided by 1. So if we're going to multiply that, all of this belongs on the top. So if you want to just think about multiplying all those and putting them all on the top, that's fine. That will work. Okay, so now that we have that set up, we can start crossing these off. I notice I've got a k minus 3 on top and a k minus 3 on bottom. I can cross both of those off. And what you'll start to notice here, we got both of those gone. The next one, I've got a k plus 1 on top and a k plus 1 on bottom. Because it's the entire quantity, I can cross those off. What you're going to notice here is we're going to get rid of all of these denominators, which is what is great if we can multiply all of the components by that lowest common denominator. That's the whole purpose. We get rid of all those fractions. Okay, I'm just left with whatever this is, this quadratic expression, this 2k squared plus 13k plus 15. That's it on this side. Everything else has been crossed off. Let's move along to the middle one here. I notice I've got a k minus 3 on top and bottom. I'm going to cross those off because those are gone. Let's see, and that's it there. Over here I've got a k minus 3 times a k plus 1. Let's see, I've got a k plus 1 on top and bottom, so I can cross those off. Alright, now that we've got all those crossed off, we have to see, notice all of my denominators are gone. So this is an important step. If you've done this correctly, you won't have any denominators left. It's all going to be on the numerator, so we're no longer going to have our fractions. Let's see what we have left with here. Okay, so we've got this one here. Notice this 2k squared plus 13k plus 15. That came from right here. That's what we were left with. Plus, and this is a k plus 1 times k. That's where that came from. And I've got my equal sign, of course. What I'm left with here is k minus 3 times k minus 2. Okay, so now what I'm going to have to do, let's see here. Let's go ahead and distribute this k here. This will be k times k is k squared plus k. Let's go ahead and distribute that. As well as we can go ahead and multiply these two together. FOIL those, or you can use the box method. Either one is okay. If I were to FOIL those two together, I end up with this. The reason why I'm doing that now is because the next step is going to be to combine all of the like terms. So it's okay to go ahead and FOIL that back in now. We've already crossed off everything. Now it's a matter of combining them all together. Alright, so I'm looking at this one here, and I'm looking on the left-hand side specifically. And I notice that my 2k squared and my k squared I can combine. I can do those two together, give me 3k squared. Also, I can combine my 13k and my k. That would give me 14k. So let's go ahead and do that now. Alright, so I've got all those in. All I did is combine the left-hand side there. Now I've got this quadratic on both sides, essentially. I've got two different ones. I need to get them all into one side. I can take these and move them all over here. I can take these and move them all over here. I notice that if I move all of these from the right-hand side to the left-hand side, that will allow me to keep my leading coefficient, this number right in front of the k squared, to be a positive number. So I'm going to do that. I'm going to move this one all over. Now I did it all in one move. Hopefully that's not too confusing. The way I get rid of k squared is I subtract k squared. The way I get rid of negative 5k is to add 5k, and the way to get rid of a positive 6 is to subtract 6. So if I did that to this side, I've got to do the exact same thing to this side. So hopefully that wasn't too confusing. I just kind of ran out of space. Alright, so if I'm going to do that, now I'm going to add all of those, combine all those together. I've got 3k squared minus k squared gives me 2k squared. 14 and 5 gives me 19k, and 15 minus 6 is 9. This side I'm just left with a 0. Okay. Alright, so now that's the majority of it. From here, we just have a quadratic. We can actually plug that into the quadratic formula. That will work. That will give us our answers. Or we can also factor these. I'm going to show you the factoring method. Quadratic formula, to be honest, is most students don't struggle with that, so I'm not going to cover that in this. You can plug it in there, though, and that will work. Instead, what I'm going to do is I'm going to factor this one. So I'm going to bring it over here. So I've got this one right here, the one on the left-hand side that I brought over here, just to kind of show you what I'm going to do with factoring. The very first thing that we're going to do when we factor these is I'm going to have two binomials that I'm going to factor them into. So I'm going to write those two binomials, sort of. I've got two k's here. 2k and 2k. I write 2k's here. I've got this other part here I haven't filled in yet, but I'm going to need to do that. Now, this is using the Berry method. This is the one we went over in class. This gets a little bit confusing because I know that this is wrong from the get-go. I've got 2k and 2k. Well, if I multiply 2k times 2k, I would get 4k squared, not 2k squared. So I know that I have too many numbers in there to start. I'm going to have to eliminate one of those. We'll do that as part of the process. Okay. But the next move is we've got to figure out what goes here and here. We've got to figure out two numbers. The way we do that is we multiply our a value times our c value. So this is 2 times 9. 2 times 9 is 18. So we need two numbers that multiply together to give us 18, but add together to give us 19, this b value here. So 18 multiplied together give us 18, add together give us 19 would be 18 and 1. So I'm going to fill those in right here. Okay, right in all of this I've got an 18 and a 1, and it doesn't matter what order you put those in because both of them have the 2k, so it doesn't change anything. Now what I do is I look to see if there are any common factors here. Well, 2k and 1, there's nothing in common there. I can't take out. This one has a 2k and an 18, so it actually has a 2 that I can pull out. So I'm going to pull out my 2 right now. That leaves me with just a k plus 9. Okay, now that is my extra here. What I pulled out there is what I'm going to cross off. So this is actually my factored form here, and you know that you arrived at your factored form if you can multiply these two back together and get your original quadratic expression. So if we were to multiply these two, if we were to FOIL them or use the box method, either one is okay. We need to get back to this original one that we started with. Alright, so now I know what my factored values are for this one, so I'm going to move those over now. There are factored values here, k plus 9 times 2k plus 1. Alright, now I'm going to get rid of this just so I have some room to work. Same thing with this LCD here. Let's get rid of those. Okay, now that I have some room to work, I'm going to rewrite this here over here. Let's bring that in if we will. There we go. Okay, so same exact thing, I just rewrote it over here so we have some room to work. When we're doing these, we're going to set each of these equal to 0. This is how we're going to solve it. It'll make our life a lot easier. So I go k plus 9 equals 0, that's the left-hand side. Then this one, 2k plus 1 equals 0. Now I'm going to solve each one of them individually. So let's start with the one on the left. Let's see, this is a plus 9. I need to get k all by itself, so that means I'm going to subtract 9 from both sides. So k equals negative 9. Okay, now over here, I need to get k all by itself, so that means I'm going to subtract 1 from both sides. I find out that 2k equals negative 1. Divide both sides by 2. I find out that k equals negative 1/2. Okay, so I've got all of my values here. I've got negative 9, I've got negative 1/2. We do need to plug those back in to make sure that they're going to work. Most of the time when it doesn't work is if something on the denominator, something on the bottom equals 0. So I always kind of plug those in real quick. If I've got a negative 1/2 plus 1, that does not equal 0, so I'm okay there. Negative 1/2 minus 3, that does not equal 0, I'm good there. Negative 1/2 squared, I plug that in. That one does not equal 0, I'm okay there. Same thing with the negative 9. Negative 9 plus 1 is negative 8. That's not 0. I'm okay. And that's really what you're looking for. As long as those don't equal 0, then you should be okay on that. That works about 80% of the time. Technically speaking, you should plug them into every one of these k's here and make sure those two are equal to each other. If it does, then those two are your answers. In this case, they both do work, so those two are my answers. This is everything I've got. This is the whole process here. So there's quite a bit to it. The very first thing is to find your lowest common denominator, then multiply each part by that. and then you're going to have to combine it and try to solve this one. This one is a difficult problem, so hopefully this helps a little bit as you're going through.